Any questions on this side? Or this is going to switch to the other side. This is still at the bottom of the front though, right?
Yes. Yeah.
Remember we did problems earlier this year. If you threw the ball up or you dropped it off of something, you had the height as a function of time. Because of gravity, the height accelerates down, right? Which is the -16. This has to do with the acceleration due to gravity, plus the initial velocity that we threw it up or down at. If we threw it down from something, from top of a building, the v sub 0 was negative, but most of the time it was a throw something up. And we had from an initial height. Now, the problem with all these questions is they assume you're throwing something straight up. Well, if I'm going to throw something straight, a ball, I'm not going to throw it straight up because I don't want it to come straight down and hit me on the head, okay? Most of the time when we throw or hit or shoot, we do it at an angle, right? Whether it's shoot a basket or throw something at someone, spit wad, whatever, okay? Or what happens when you hit a baseball at an angle to the ground or hit a golf ball,
Bounces up.
okay? So, the issue here, guys, imagine this is a golf ball, hit it with an initial velocity of 140 feet per second. So the path it leaves makes a 31-degree angle with the horizon, or the horizontal line there. Imagine the golf ball starts at the origin and travels in a direction of the positive x-axis. If there is no gravity, the distance it traveled would be a function of x and y, okay? Vectors, does this look familiar? 140 cosine 31 and 140 sine 31? Remember the vector components? X equals 140 cosine of 31. Does this look familiar? 140 sine of 31. Okay? Guys, please stop talking. Okay? We have to put these into our fancy equation that we started with. Y equals -16 t squared plus v sub 0 t plus h sub 0. Okay? This x component is going to be what's causing it to go this way. We're going to write that here. 140 cosine of 31. And I'm going to put the t at the back. I think the book usually puts 140t cosine of 31, just so you know. And back here, this y is affecting the height here. We're going to put it here. So it's -16t squared. I'm going to go over that because I don't want you to forget that's there. Plus 140 sine of 31 t. And now this was off the ground, so there is no initial height. So this is just 0 for h sub 0 back here. All right. Before we try to type this in, we need 3 things to think about in terms of the x and the y, or in terms of graphing. T is time. When you hit a golf ball, what do you think? How many seconds till it hits the ground?
Sure. 4.
2, 3, 4. We could try 4, okay? I wouldn't start out with 10 because do you remember the calculator has to calculate all this stuff and it takes forever? If it stops in midair, then you know you need to add a little more time, right? So I would start with something small. This is a golf ball. I think it's going to go pretty far. X is how far away from us it goes in feet. I don't know, somebody throw out a number.
200.
200 feet, okay? How high does it go?
300.
I don't know. I think those might be backwards in terms of proportionally, but let's try it. What mode are we in now? Uh-oh. Mode problem.
We go to degree, right?
We need to be in degrees, but we are still in parametrics. Degrees. Make sure you go to degree mode or this isn't going to work. All right. The first one, x, is just the component. So it's 140 cosine of 31. Close your parenthesis and then put your t, or you can put your t out in front. And this one is negative 16 t squared plus 140 sine of 31. Gotta have a t after that. Close your parenthesis and put a t. And then there is no initial height, so we won't have anything to put on the back. All right, we're gonna go to our window. We are talking time this time, so we said we'd try 0 to 4 seconds. I'm going to leave my t-step 0.1. X is distance away from me. We decided to start with 0 to 200. Scale doesn't really matter. And Y is height. It's not going to go underground, so 0 to 300 was Jacob's suggestion. Okay, graph.
We need to keep going.
Okay. We need to move, which one do we need more of?
X.
X. So I'm going to change the X max. We can go 1,000. Okay. Uh-oh. It stopped in midair, so we need a little more what? Need a little more time. So I'm going to go 0 to 5 seconds, or 6 seconds should be fine. All right. So I'm going to erase this. Did anybody find a window that's really nice? I mean, this works, but
I think 0 to 100 for the Y.
100 is high enough?
Yeah.
Okay.
Oh, yeah.
And like 800, 700, 600 works? Okay. As long as it's in the realm, it shows up on the screen, your answer on your test or quiz will be fine. Guys, this is part of the test, okay? If you put down negative 10 to 10 and negative 10 to 10, I'm not going to count it right. We don't need negative time. We don't need negative x-axis. We don't need negative y-axis, okay? So be reasonable here. Now, do trace. When you do trace, this is where it starts, and this is where it is at each time. What is the highest it ever gets? Can you try to figure out about where the peak is, and you can't do max with this? Look at the y value. What's the highest it ever gets? 81 something?
81.2.
Okay. So it goes about 81 feet up in the air at 2.3 seconds after we hit it, right? And at that point, it's about 276 feet away from us. Everybody understands that x is distance away, y is height, okay? Keep going till it hits the ground. What do you want to be 0 then? You want to get the y value as close to 0 as you could. 540 gets me pretty close. So, question, how long is it in the air? Right here it says 4.5 something, right? So about 4.5 seconds and it hits the ground. How far away from me does it land? I got 540-ish, and it will depend exactly. You know, I have to give you some leeway on this because you can't get it. If you wanted to be a nerd like me, you know, you could go trace and put in like 4.41, 4.42, and see how close to 0 you could get that.
How can you even tell with the water there?
Yeah, my axis isn't in very good shape here. Is it 4.5 something? Is that why I'm not doing so well? What did I just do?
Zoom fit?
Okay, didn't mean to do that.
No, you didn't hit zoom fit.
I hit something that did a mess. All right, when does the ball hit the ground? Somebody have a better answer than me? It's about 4.5, 4 point, okay. That's what I was doing 4.41 instead of 4.51, like a crazy person. How far from the starting point does it land? What was the X?
540.
Around 540, was this feet? Okay. So what is the maximum height? We said it hit a max somewhere up here of Y value at, okay. Now, those are estimates because our calculator in parametric mode doesn't let us calculate a 0 or a max. Okay? One more question. This one's really fun because I'm going to show you. Oh, on your picture here, just draw yourself that this is our cosine of t, our cosine of theta, and this is our sine of theta. Okay? It's related to the magnitude of the vectors. Remember that? Okay. I want to do this last question because it says a batter hits a ball 3 feet above the ground. So what is that telling us? H sub 0 is 3. Okay? So we're going to put a plus 3 on the back. The ball leaves the bat with an initial velocity of 138 at an angle of 26. So what goes on this blank? 26t. And back here, it's negative 16t squared plus 138 sine of 26t plus 3. All right, appropriate window. Give me a guess. 300 feet away? High? It says there's a fence 400 feet away, so I'm thinking it is going to have to be more like 500 feet away here. Height? What do you think? 100 is enough, maybe? 5 seconds? I don't know. Let's see if that works. And then I'm going to teach you to draw the line. That's the fun part on this question. 0 to, what did I say, 500 feet away, maybe? 600 is better? Okay, thank you. Oh, I wasn't that smart. Remember, I messed my window up, so. Okay, it was 138 cosine of what?
26t.
Okay, so our angle was 26. And this one needs to change to 138. And we need a plus 3 on the back, right? Because it came off the bat 3 feet above the ground. All right. There's the ball. Path of the ball. Actual path of the ball this time, right? Because it really is doing a height up and down. Now, the easiest way to answer the question about the bat, about whether it clears the fence, if the fence is 400 feet away, what do we want to do? Trace out to 400 feet. So 400 on the X or the Y, guys? It's going to be a problem if you try to do Y. 400 on the Y. When you get out to 400, it's about 32 feet in the air still, right? Will it clear the fence that's 25 feet tall? Okay. Yes?
Yeah. That's 33 feet.
So out here somewhere is a fence. How far away did it land? Can anybody tell me? It started 3 feet.
496.
About 500 feet away it landed. Okay. And how high? Did anybody figure out how high it went? Didn't ask us this, but
68.
about 68 feet up. Anyway, just an estimate. We want to draw, I want to show you how, just for fun, to draw the line on your calculator, okay? Everybody go to the home screen. So quit out of this. And there is a draw feature on your calculator. It's second program. Second program. And we're gonna go to draw a line. Okay? No, we're not gonna free draw this. Okay, I didn't look, so I can trace that in a second. Go to the home screen, second program, draw, pick draw line. We need the endpoints. All it's doing is you give it 2 endpoints and it connects it. So one is 400 feet away, so 400, 0. comma, 0, comma is above 7. And then we have to put a comma and then the height of the wall. So at 400, we need to go up to 25, above the 7. So we're going to go 400, comma, 25 is the other end. Okay, hit enter and all it says is done. It wasn't very exciting, but then it should go to the graph. Or if you go to the graph now, there's a wall and it shows it going over. How cool is that? Okay, now I'm going to trace along because Ben said he didn't get this answer. What was the height? Yeah, I only got about 60 feet, not 68. Okay. So this one should have been about 60 feet. But yes, height at x equals 400 is about 32 feet. So it clears the wall.
This hot part, could you like make that little ball go across this so it looks like it's going?
Oh, yes. We're going to turn the little ball on. If we go back here, go to, okay. Okay, you go back arrow when you're in the x equals. I'm going to actually do the one that doesn't even trace, that just shows the ball. Here it goes. Dun, da, da, da. Okay, yep. The line goes away. It's okay. If we go second, back here, quit, and hit enter again, it'll draw the line. Oh, it didn't make the ball go again, though. I don't know if it's going to work now.
Maybe we should have it draw the line.
Like the line, all my lines are gone.
Now it doesn't want to do it again. Okay, I'll turn it back on here.
Okay, you gotta turn the line with it on and then
If you turn back and forth between one and the other, ah, the line is gone again.
okay, no,
The
no,
wall is gone.
The line will come up after.
It's the shoe.
Wait.
That's my story.
Okay.
Wait, did you hit enter
I'm gonna
on the home
quit,
screen?
go enter on the home screen. There it is.
Oh, yours didn't draw it.
But as soon as I tell it to redraw it, it doesn't draw that line, I think. Okay, we need to stop recording because this is ridiculous. We're just playing around.